So now we're going to do some of our practice when it comes to balancing redox reactions. And so as we did before, we need to start by splitting these into the two half reactions. We have our chromium half reaction and our bromine half reaction. Our first step is to balance all non-hydrogen and non-oxygen atoms. In the first half reaction, the chromiums are equal, so we don't have to do anything. In the second reaction, we need a 2 out here in front of bromine to balance. The next two steps, which are to balance hydrogen and oxygen, we don't need to do anything with the second half reaction because there are no hydrogen or oxygens in that reaction. But for the first reaction, we do. And so you can see on the left, we have 3 oxygens compared to 4 on the right. So we need 1 water to balance out the oxygens. But that means we now have 5 hydrogens on the left and none on the right. So we need 5 H plus over here in order to balance hydrogen. Next, we need to balance charge. In our first reaction, we have a total of 0 charge on the left side and plus 3 on the right. That's coming from the -2 with the chromium species, and then 5 times plus 1 for the H plus, a total of plus 3. So to balance that, we need 3 electrons. Down here, we're neutral on this side, and on the right side, we have a total of -2, so we need 2 electrons. Now, our next step is that we need to multiply our equations so that our electrons are equal. So we can get 6 electrons in both equations by multiplying the first one by 2. And the second one by 3. Now you can see that what we were trying to do was balance our numbers of electrons. We have 6 electrons on each side. Now before we combine those half reactions, one of the questions that I want you to answer later about each of these reactions is to tell me what's being oxidized and what's being reduced. Well, this is actually the spot where it's good to answer that question, because certainly we can go through the process of oxidation numbers, and we would see, for example, that bromine Br2 has an oxidation number of 0, being an element in its elemental state, whereas Br minus, being an ion, has an oxidation number of -1. And so we can see that it's being reduced. But another way that we can see that, we are adding electrons to the bromine. Because we're adding electrons to the bromine, that's our reduction side. The chromium half reaction is being oxidized. And so it's the chromium that's being oxidized and the bromine that's being reduced. But now we can add these two half reactions together. We don't put the electrons in because they cancel. The last thing that we need to do here is to take this one to basic conditions, because right now the H plus shows that we're under acidic conditions. So the way we do that, remember, is to add hydroxide to both sides that's equal to the number of H plus. So each side gets 10 hydroxide. But on the right side, hydroxide plus H plus forms water. So our 10 H plus 10 hydroxide will give us 10 water. Now we already have water on the left side, so anything in common to both sides we can cancel out. So that means we can get rid of 2 waters from each side. And on the right side we're left with 8. On the left side they go away, and I'll just move the hydroxide up to give us our balanced equation. Alright, so let's go on to number 2. Again, we split into half reactions. SB going to SbO2 minus. And O2 going to H2O2. Alright, so first we balance anything that's not hydrogen or oxygen, and that's only antimony, which we have 1 of on each side. Now we balance oxygens by adding water. Our first equation has 2 oxygens on the right and none on the left, so we need 2 water. The second equation has 2 oxygens on each side, so we don't need to do anything. Now we balance hydrogens by adding H+. So in the first equation we need 4 H+ to balance out the 4 hydrogens from water. And in the second equation we need 2 H+ on the left to balance out the 2 hydrogens that are there. Now, what are our charges? First equation we have -1 and +4, so we have a total of +3 compared to the left side, which is neutral, so we need 3 electrons. In the second equation we have neutral on the right, +2 on the left is 2 electrons to balance that out. Now we're going to need to multiply through on these equations in order to equalize our number of electrons. We can do that by multiplying the first equation by 2, the second equation by 3. To give us our new equations. And now these are the half reactions that we can combine. Again, we can now note what's being oxidized. We can see that the antimony half reaction is the one that's giving up electrons. So antimony is oxidized. The oxygen half reaction is the one that is gaining electrons, so it's oxygen that's being reduced. So now we add these 2 equations together. And the electrons cancel. Now, this one is under basic conditions, but before we do that, we should cancel anything that we can. So notice we have 6H+ here and 8H+ on the right side, so we can cancel out 6 of these. So those go away, and this 8 becomes a 2. Now to convert this to basic conditions, we add a corresponding number of hydroxide to each side. But the 2 H plus and the 2 hydroxide will combine to form 2 water. Now those will cancel out with 2 of the water molecules on the right. So overall that will go away, and we get 2 over here. If we want to prove that this is balanced, we should be able to go through and add up all of our elements just like we can with any other balanced equation. And if we do that, we find that yes, everything is balanced. All right. Next one, we're now dealing with acidic conditions. So we have HCOOH, which is known as formic acid, being converted to carbon dioxide, and permanganate being converted to manganese 2+. So our carbons and our manganese are already balanced. Those are our non-hydrogen, non-oxygen elements. So now we balance oxygen by adding water. For the first equation, we have 2 oxygens on the left, 2 on the right. That doesn't need anything. But the second equation, we have 4 oxygens on the left, so we're going to need 4 waters to balance that. Next, we balance hydrogen. The first equation needs 2 hydrogens to balance the 2 hydrogens on the left, and the second equation needs 8 H+ to balance from water. After that, we need to balance charge with electrons. First equation is neutral on the left, but +2 on the right. Therefore, we need 2 electrons. The second equation is +7 on the left, but only +2 on the right. And so we need 5 electrons. What's our next step? Our next step is that we need to make sure the number of electrons are equal. We can do that by multiplying the first equation by 5. And the second equation by 2. And then we can add them together. So 5 formic acid plus 16 H+ plus 2 permanganate gives us 5 carbon dioxide plus 10 H+ plus 2 manganese 2+ plus 8 water. Is there anything we can cancel out at this point? The answer is yes. We have 10 H+ on the right, 16 on the left, so we can get rid of 10 on each side, and we get our balanced equation. Finally, what's oxidized? Well, the formic acid is giving up electrons, so this carbon is oxidized. The manganese half of the equation is gaining electrons, so this is the reduction side. Now you might ask here, the manganese, its ion is going from -1 to +2. How is that gaining electrons? But if you calculate the oxidation number of the manganese, the oxidation number of this manganese right here is +7. Remember, oxygen is generally -2. There's 4 of those for a total of -8. So to get to a -1 charge, we'd need an oxidation number of +7. In the product, the manganese itself is only +2. So we can actually see that the manganese has in fact been reduced by 5 electrons. So again, same steps here. We write our 2 half reactions. We balance iron. Don't have to balance carbon, it's already balanced. Balance oxygen by adding the appropriate number of water molecules. Balance hydrogen by adding H+. And then balance charge by adding electrons. Now in this case, we have 6 electrons in the first reaction and 2 in the bottom reaction. So to balance the number of electrons, we don't need to touch the first one. All we need to do is multiply through by 3 on our second reaction. From here, we can just combine the reactions. What can we cancel at this point? Well, H+, we have 6 on each side, so they actually all go away. And we have 3 waters on each side, so remarkably all of those go away. Now, is what we have left as a result balanced? 2 irons on each side, 3 carbons, and 6 oxygens. So it is balanced. This is a fairly unusual situation, again, because we don't usually see all of the H+ and all of the water molecules canceling each other out. But there are times where it happens. And so that's the result we get for the balanced equation. Again, from the electrons that are being transferred, we can see because the iron half reaction is gaining electrons, that's our reduction, and the carbon is being oxidized because it's giving up electrons. All right, one final example. This one is in basic conditions. I'm going to do this one in a little bit different way, just to show you that there's an alternative way to do it. So our first step, balancing non-hydrogen, non-oxygen, after we've written our half reactions, is already done. The carbons are balanced, the iodines are also balanced. Then we can add water to balance out oxygen. And then we can add our H+ to balance hydrogen. Now, in the past examples we've done with basic conditions, we've waited till the very end to replace H+ with hydroxide. But there's no reason that we can't do it here. So let's do that. So we know now that our 2 hydrogen plus 2 hydroxide will form 2 water. Now one of those waters will cancel with the water that's already there on the right side. So what we'll be left with over here is one water and no water on the left side. Same thing with the second equation. We have now 10 waters on the left side from combining the hydroxide and H+, and that will cancel with five of the waters on the right side. So these 5 go away. And we're left with 5 water over here. So ultimately, this isn't going to change anything that we do in the solution. It's just doing things in a different order. Now we'll add in our electrons. The first reaction has a -2 charge on the left, neutral on the right, so we need 2 electrons. The second equation has a -10 charge on the right, neutral on the left, so we need 10 electrons over here. So again, this shows us the oxidation and reduction. We can see that carbon is being oxidized because it's losing electrons, and we can see that iodine is gaining electrons because it's being reduced. Before we can combine the reactions, we need to equalize the number of electrons. As we've done before, we do that by multiplying one or both of the reactions as necessary. With 10 electrons here and 2 here, if we multiply through the first reaction by 5, then we'll have 10 electrons in both. Now we can add these two reactions together. We get 10 hydroxide plus 5 water plus 5 carbon monoxide plus I2O5 gives us 5 carbon dioxide plus 5 water plus iodine plus 10 hydroxide. As always, at this point, we should cancel anything that's the same on both sides. 10 hydroxide cancels with 10 hydroxide. 5 waters cancel with 5 waters. And we're left with our balanced equation.